All right. Good morning, everybody. Thanks for coming. I'm really grateful for you to be here. My name is Raffaele Dal Pozzo. I work for company Enerblue. I'm an application specialist in this company. And today I would like to present some information about R-290 as a refrigerant, our friend propane. When we talk about R-290, it's always something very interesting, but also something kind of dangerous, okay? So it attracts us, but we're scared of it, okay? So I think the best thing, the most important thing that we can do is getting to know it a lot better so we can understand how we can manage this R-290, okay? Because it offers great possibilities. And today, I would like to say a few words about Enerblue company, just very briefly, and then we will go through some information related to the normatives that stays around the management of R-290 for the building of the units and also for the management of the installation area. So it's something that involves both constructor of equipment and also installers. Talking about the Enerblue story, I'm not telling you the story of the company, but Enerblue has always been a company which was focused to natural refrigerant. Since 2012, it started to develop machines with CO2, and they were actually heat pumps with transcritical cycles. And immediately after starting to work with natural refrigerants, we saw the possibilities that were also on propane as a refrigerant. There are a lot of characteristics of propane that make it a very, very good refrigerant. And so after our first prototype in 2013, we realized actually the first line of products, and we sold the first unit with refrigerant R-290 in 2014. Our main partners were Nordic partners from Norway especially, but also Denmark and Sweden. And we started a cooperation with them, which is still lasting today. And so that's why we are bringing to this exhibition this year this motto, let's say, 10 years forward, because since lots of constructors, they start to build their new product with R-290, we're actually celebrating today our 10th anniversary of working with propane. And so I take this occasion to invite you all tomorrow at our booth, 3:30 p.m. We will celebrate together with our partners, Norwegian partners, our 10th anniversary of using propane for heat pumps. But let's go back to the main point of this presentation. The normatives that stand behind the use of propane is mainly EN 378. And but I want to discuss a little bit also about some characteristic of propane. Of course, propane is an explosive refrigerant, so is A3 refrigerant. And this is what makes us fear a little bit. What we have to know, what we are attracted from is that it is a natural refrigerant, and the GWP is just 3. So it is a green refrigerant. We can use it, and we will be able to use it a long time, for a long time, also according to the European normatives. Some informations that are interesting are, for example, the weight, molecular mass of this refrigerant. Why? Because it is dangerous, it's true, but we know how it behaves. It's very heavy. So when there's a leak of refrigerant, it goes on the ground, it stays on the floor. If you actually see that, I don't know if you ever had the opportunity, maybe in a testing lab, you can actually see that it goes down and that it can stay in a can. It doesn't come out. It stays inside there and it behaves. It's similar to a fluid, okay? You can actually see that. And so with all this information, including the fact that the auto-ignition temperature is 470 degrees, so we have to stay below that to avoid the auto-ignition. These are information that help us to manage this refrigerant, to know what we're doing with this refrigerant, and not be afraid of using it, because we know how to do it. The normative that helps us in this task is EN 378. This normative actually exists from a long time, if I'm not wrong, from 1994. And it is used to manage the safety of, let's say, dangerous refrigerant machines, like ammonia chillers, for example. The fact that R-290 is now being used all over, also in residential application, helped the normative to be updated, also to include more information and to be more precise and to help us construct more safe units, material. So it is divided in four parts. The first one is related to basically definition of things, classification of areas, criterias, what we have to know, what we have to do, talking about this refrigerant. The part 2 is more dedicated to constructors of equipment. So it's more interesting for Enerblue, of course, and for other constructors. And part 3 is instead dedicated to the installation areas. So the risk assessment that has to be done in the area where a heat pump with propane is installed. And part 4 is instead interesting for doing the maintenance and for doing also disposal of the units and so on. EN 378 is a normative that refers also to the ATEX normative. Of course, when we talk about explosive areas, explosive equipment, it's always ATEX is the main, let's say, reference to have information about it. And in this slide, I simply reported a few information about the areas we're talking about. So zone 0, for example, is an area where you can have a continuously the presence of an explosive area, explosive atmosphere. Zone 1 is a zone when it is possible, it is likely to happen that you have an explosive atmosphere also during normal operation time. While zone 2 is instead a zone where you normally don't have an explosive atmosphere, but it is possible that this happens usually when there are some malfunctionings or some faults of the equipments. So when we talk about a heat pump, of course, it is not designed to create an explosive atmosphere, but it has to manage an explosive atmosphere in case this happens, so during faults. So the normatives are always moving in this ambient, zone 2, ATEX area, and the possibility that there is a leakage and how to manage that. So getting a little deeper inside the units we're talking about, and so the risk assessment related to the construction and the design of the equipment, EN 378 has got basically two approaches that allow us to design a heat pump that handles R-290 as a refrigerant. The first one, which is also the historical one, let's say, it's the theoretical approach. This theoretical approach refers a lot to the ATEX normative because it basically stays on the concept that there can be an uncontrolled leakage, so some leak that comes out of the unit and we don't know where it goes, or there is a controlled leakage. So the fact is that the coils outside of the unit are a sealed, hermetically sealed equipment. So even the ATEX normative is not really considering that there can be a dangerous amount of refrigerant coming out from the coil. But all the components that are not hermetically sealed, let's make a stupid example like semi-hermetic compressor. By definition, this is not hermetically sealed. Okay, there can be a leakage. So all the components that are subject to have leakages should be included in a specific box. And in this box, we can manage the leak. So if something happens, we know it happens in there, and we have the power, with the knowledge of the normative, to manage this leakage in order to avoid any damage. And of course, there can be several approaches to this. When you have a controlled leak area, you can decide to apply every component which is inside there and to make it an ATEX certified component. This is an approach. There's another approach which could help you to avoid that the concentration of propane inside that area ever becomes flammable. Okay, so you try to put equipment like a ventilation and so on to avoid actually a concentration of propane that becomes dangerous. I'm not here to tell you all the possibilities. You have to do your own risk assessment. Of course, there is another approach that the normative allows us to use, and this is a newer approach. It comes from an update of the normative in late 2021, if I'm not wrong, and it's called the experimental approach, the fun approach, let's say, because it requires to make some tests and to actually simulate what happens with the leak of propane in the unit and gain knowledge about this. So this is a more, let's say, heavy approach. It requires more research. It requires also, what we did in our facility was asking to a consultant to define an area as an ATEX zone 1, because during normal activities there would have been an explosive atmosphere, and do lots of tests in this ATEX zone 1, okay? And this approach gives you lots of knowledge because you simulate a leak of propane in different quantities, in different areas, in different directions inside the unit. And you can know what happens to the refrigerant inside the unit. This helps you to create all matters of safety inside the machine to avoid any type of danger. So we remember, avoid surfaces that go above 417 degrees, for example, and avoid any kind of spark, and decide whether you need or not ATEX certified components, or if you're able to actually remove the concentration of propane from the area and actually never create an explosive atmosphere inside the box. This approach allows you to do this, to understand what you can achieve with the safety measures you apply. Of course, every component that has to work during the possible formation of a explosive atmosphere have to be ATEX certified. Okay, this is a must. Okay, even if you make tests and if you see that you are actually cleaning the area from from being explosive, but the safety components, and here from our experience, I'm talking about an extraction fan that cleans the area. I'm talking about a leak detector. We also put, for example, a differential air pressure gauge inside and outside the compressor box to understand if the fan is working. So we put a safety on the safety. Okay, all these components that have to work in a possible explosive atmosphere, they have to be ATEX certified. Okay. So we can go a little on with the talk. I know I'm not giving you too deep information. We can talk about it later if you come at our booth. I'm willing to do that, but the time is what it is. So we talk about the installation area now. Of course, we design the unit, we prepare the unit, we make our own risk assessment, we ask consultants, we have technical people and so on. We follow the normative rules, but then we take this unit and we put it in an installation area. So first, there are some information that we have to share, that the constructor of the machine has to share, because there is a risk of the machine which can be handled by the safeties inside the machine. And then there is a residual risk which is communicated. It's outside of the unit. If I have a leakage inside the machine and I am able to take this propane outside of the unit, I have to communicate the quantity of this refrigerant that comes out from the unit. So once we know the concentration and the flow rate of this propane that can come out from the unit, I can understand how to manage that in the installation area. So what I'm telling you now is just some, let's say, good practice information, okay? Because as a constructor of the unit, we cannot be reliable for what happens in the installation area. Well, not totally, at least. There has to be a risk assessment of the installation area. So what we suggest is to consider that when there is a small leakage coming out from the unit, or at least a leakage considered according to the normative EN378. Usually we talk about 3 grams per second. In about 2 meters distance from the unit, this amount of refrigerant is diluted in the air in a way that it is not more dangerous. So our suggestion is to keep the area free around the heat pump in about 2 meters, okay? This is not a must. This is an idea, because the conditions of the area can change a lot, okay? Remember, propane is going down. So if there is any window, if there is any discharge pipe or any stairs, any place where propane can go inside from the top, they can become a dangerous area. So these places must be away from the unit. Or you can do any other possible treatments to the area around to reduce this distance. For example, you can ventilate the area around, okay? These are measures you can consider to do when you talk about the installation area. Another interesting information is that this area should not be available to access from normal people. Only technical people should access this area. I've seen heat pumps installed like in a parking spot. This is absolutely not very good, because also cars are passing by and they might have also parts warmer than 470 degrees. I don't know. There can be sparks, of course. And so this is not good. Remember one thing. We are now coming in the market of R-290. It's a great opportunity for everybody, I think. But if one of these machines creates danger, if one machine explodes, for example, it destroys the market. So I think it's in the interest of everybody, not just of Enerblue, that when we do a risk assessment, we do it with perfect knowledge, and we do it in a perfect way so that nothing like this happens, because it will damage everybody. So when we talk about the installation side, we also have the units that are installed internally, okay? There is a difference here between machines that have more or less than 5 kilos of refrigerant in each refrigerant circuit. If the refrigerant circuit only has more than 5 kilos inside, you have to create a machinery room. What is a machinery room? EN378 part 1 gives you the definition and criteria to manage that. Okay. Last thing, of course, take a picture of this. We like to use a safety electrical board for our units, but that's just one of our choices in order to avoid electrical supply to come inside the unit in case of leak, and only to power ATEX certified components. Very last thing is this. When you do the risk assessment of the area, you have to consider that there can be a failure inside the heat exchanger, the user heat exchanger. So the refrigerant can mix together with the water and go inside the water pipes. So either you put an intermediate heat exchanger, but it's not really effective. We suggest to put a bleeding valve, automatic bleeding valve, so that in case there is some propane flowing in the water pipe, this bleeding valve is simply discharging the propane in the area. And the area around this bleeding valve has to be considered a risk area according to the risk assessment. Maybe an ATEX zone 2, I don't know. Okay, so I hope I gave you some good information. I hope I gave you some things to think about, some possibilities to take. And of course, I thank you a lot for being here with us. And I renew my invitation for tomorrow's event at our booth. We will celebrate 10 years of using propane machines. There will be a cake and Prosecco if you like. So, of course, you're invited. Thank you very much.